Okay, binomial theorem. You're going to wonder, why in the world did we study Pascal's triangle? What does it do for us? Well, I'm going to show you in a few minutes. The screen will go blurry, but only momentarily. I just want to make sure it's as clear as possible. Okay, so do you remember multiplying binomials? We're going to do all of these. Okay, what's x plus y to the 0? X plus y to the 1. Do you notice the coefficients are 1 and 1? So x plus y squared, well, that's going to be x squared plus 2xy plus y squared. Agreed? Are we okay with that? Because we have the FOIL. Now our work starts. Okay, we're going to go. I'm going to use the product of the last example, and we're just going to multiply that by x plus y to get x plus y cubed. So we're going to go x times x is x. X times x squared is x cubed. X times 2xy is 2x squared y. X times y squared is xy squared. Y times x squared is x squared y. And then y times 2xy is 2xy squared. And y times y squared is y cubed. And that is equal to x cubed. So let's see, add up like terms. So we're going to add that. That's going to be 3x squared y plus, Yes, you're right. This should be x cubed. My bad. Oops. This is x cubed plus x squared y plus 2. That's going to be 3xy squared plus y cubed. So just look at, I want you to notice something. I'm just going to write a bit of Pascal's triangle up here. What do you notice? Notice the coefficients. That is 1. And that's 1, 1. See, 1, 1, 1, 1. 1, 2, 1, 1, 2, 1. 1, 3, 3, 1. The ones here are understood, right? You see how we can get the coefficients of a binomial expansion by looking at the row. Okay, so this is row n equals 0. Remember, the row numbers start with 0. That's row n equals 2, n equals 3. Okay, let's now do x plus y to the 4. We'll multiply it out, and we'll see if we get the n equals 4 row. 1, 4, 6, 4, 1. What do you think? Do you think that's going to happen? Let's find out. Okay, let's actually multiply. This is x cubed plus 3x squared y plus 3xy squared plus y cubed is equal to x to the 4 plus 3x cubed y plus 3x squared y squared plus xy cubed plus, now I'll multiply everything by y, x cubed y plus 3x squared y squared plus 3xy cubed plus y to the 4. Okay, so we have x to the 4. Now let's add up all our x cubed y terms. No, that's not x cubed y. Do we have another x cubed y? Right there. So that's plus 4x cubed y plus, let's see, let's do our x squared y squared. There's 3 and plus, there's 6x squared y squared. Now our x y cubed, there's 4 of those. And then there's 1 y to the 4. Oh, do you notice our 1, 4, 6, 4, 1? Interesting, huh? Okay. All right, so it says here, examine the coefficients of the terms for each expansion. What do you notice? Let me just, for the interest of time, the coefficients, there's more than one, of each expansion correspond to a row in Pascal's triangle. Okay. The exponent of the binomial matches the row number. Examine the variables and exponents in the expansion of x plus y to the 4. What do you notice about the powers of x? What pattern do you notice about the powers of y? Well, look at x. It's going 4, 3, 2, 1. Oh, no, wrong one. Here it is. 4, 3, 2, 1, 0. X to the 0 is 1, right? And on y, it's y to the 0. So 0, 1, 2, 3, 4. It's either 4, 3, 2, 1, 0, or 0, 1, 2, 3, 4. So let's get that down. Yeah, well, the first, whatever is in the first position goes down, and whatever's in the second position will go up. Because you're not always going to get easy ones like that. Okay, so the powers of x descend from 4 to 0. The powers of y ascend from 0 to 4. Do you notice that 3 plus 1 is 4? When you add the exponents, it adds up to 4. Like 2 plus 2 is 4. 1 plus 3 is 4. 4 is 4, right? The sum of the exponents add up to 4. How is the exponent and total number of terms related? Well, when n is 4, when the exponent is 4, we have 1, 2, 3, 4, 5 terms. When the exponent is 3, we have 1, 2, 3, 4 terms, right? So, when the exponent is n, there are n plus 1 terms. Okay. So if n equals 5, because we're going to expand x plus y to the 5, we're hoping to get these coefficients, 1, 5, 10, 10, 5, 1. But for the row n equals 5, how can we use our choose button or our combinations button to get these? How do we get the 1? We go 5, choose 1, right? To get the, no, 5, choose 0, my bad. To get the 5, we go 5, choose 1. Oh, I'm sorry. To get the 5, we go 5, choose 1. To get the 10, we go 5, choose 2. To get the 10, we go 5, choose 3. To get the 5, we go 5, choose 4. And to get, remember that? We did that on Friday. Right? So the elements in Pascal's triangle can be obtained by using the combinations button. So let's do this expansion. X plus y to the 5 is equal to, what's my first coefficient? 5, choose 0, right? And it's going to be x to the 5, right? Y to the 0 plus 5, choose 1. No, I'm just doing it to emphasize the patterns. This is going to be x to the 4, y to the 1 plus 5, choose 2, x to the 3, y to the 2 plus 5, choose 3, x to the 2. Notice the decreasing pattern of exponents on x. 5, 4, 3, 2, and its y will be 3. And then 5, choose 4, x to the 1, y to the 4, 5, choose 5, y to the 5. 5 choose 0 is 1. Y to the 0 is 1, so this is x to the 5. This is 5. 5 choose 1 is 5. X to the 4y. 5 choose 2 is 10. And you know you can do that by plugging it in your calculator. The next test, your next test is on June the 1st, and it is a calculator test. Like this. Okay. Y squared plus 5 choose 3 is 10. X squared y cubed plus 5 choose 4 is 5. X y to the 4. 5 choose 5 is 1, and that's y to the 5. So notice the pattern. 1, 5, 10, 10, 5, 1. That's row n equals 5 in Pascal's triangle. Good? Just one sec. Yes.
So you have to know all the numbers in each row.
Sorry?
You have to know the numbers in each row. No, you can just use your calculator. I just use my calculator.
Yeah. It's a calculator test. Sorry? Oh, do you want me to put it back? Let's summarize. The expansion of a plus b to the exponent n is of the form, okay, n choose 0, right? The exponent is n. A to the n plus n choose 1, a to the n minus 1, because the exponent on the first term is decreasing by 1, whereas now the exponent on the second term is increasing, plus n choose 2, a to the n minus 2, b squared, plus n choose 3, a to the n minus 3, b to the 3, plus dot, 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 dot. I'm going to go to the second last term, which will be n choose n minus 1, a to the 1, b to the n minus 1. And the very, very last term will be n choose n, b to the n. Where the coefficients of each term, n choose 0, n choose 1, n choose 2, dot, 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 n choose n minus 1, n choose n, correspond to elements in row n of Pascal's triangle. I don't know if I told you, but the next two tests are the tests that can help you pull up your marks, because they're very straightforward. It's not like trigonometry, which isn't so straightforward. In any expansion, there are n plus 1 terms in total. Thank you so much. Their data projects were due today. Okay. All right, expand each of the following. Ready? Are we ready? Okay. Leave yourself plenty of room. So the exponent is 5. So 5 choose 0 to the, and 2x, right? The first term is 2x to the 5. Plus 5 choose 1. 2x to the exponent, now 4, because the exponent on the first term goes down by 1, and it's y to the 1. Plus 5 choose 2. 2x to the 3, y squared, plus 5 choose 3, 2x to the 5, 4, 3, I'm going to just make sure I'm not having a senior moment. 2x to the 2 y cubed plus 5 choose 4. 2x to the 1 y to the 4 plus 5 choose 5 y to the 5. 5 choose 0 is 1. What's 2 to the exponent 5? 32, right? X to the 5. So it's 5 times 2 to the 4 is 16, right? X to the 4y. 5 choose 2 is 10. 2 to the 3 is 8. X cubed y squared. Plus 5 choose 3 is 10. 2 to the 2 is 4. X squared y cubed. Plus 5 choose 4 is 5. 2 times 2, right? Xy to the 4. 5 choose 5 is 1, so it's y to the 5.
Is it 5 times, like the 5 choose 3? It's, no, the one after the 10 times 4x. Yeah, the one after that. What is it? 5 times 2?
2, yeah, that's a 2. 32x5 plus 80x to the 4 plus 80x, right, thank you, plus 80x cubed y squared plus 40x squared y cubed plus 10xy to the 4 plus y to the 5. See, isn't that better than multiplying that out 5 times? Notice when the exponent is 5, we have 1, 2, 3, 4, 5, 6 terms, right? 5 plus 1 terms. The next one is a little bit more complicated because of the minus sign, but not too much more complicated. Just a little bit more complicated. Huh? Watch. Ready? Okay. I apologize for the rush. Normally I would let you give it a try, but I'm just trying to get in a lesson and a half today. Okay, so we're going to start out with what? 6 choose 0, right? It's 3x to the 6 minus 2y to the 0. If you don't want to write that, that's fine, because it's just 1. 6 choose 1, 3x to the 5 minus 2y to the 1. 6 choose 2, 3x to the 4 minus 2y squared. Don't forget your minus. Notice when the exponent is even, you'll have a positive term. When the exponent is odd, you'll have a negative term. So it's going to alternate, negative plus, negative plus. Plus 6 choose 3, 3x to the 3 minus 2y to the 3. Plus 6 choose 4, 3x to the 2 minus 2y to the 4. Running out of room, so I'm just going to finish it off here. 6 choose 5, 3x to the 1 minus 2y plus 6 choose 6, 3x to the 0, excuse me, minus 2y. Oh, this should be to the 5, right? This one was to the 4, a little bit, make that a little bit more clear. And this one is to the 6. I don't like that 4 looking like that. That's no good. Now we have to simplify. 6 choose 0 is 1. 3 to the exponent 6 is 729 x to the 6. Now, the exponent is odd. We're going to have a negative term. So this is going to be 6 times 3 to the exponent 5 times negative 2 is negative 2916 x 5y. Now, here the exponent is even, a negative times a negative is a positive, so we're going to have a positive term here. 6 choose 2 times 3 to the exponent 4 times negative 2 all squared is going to come out to be 4860 x to the 4 y squared. So we did that one, we did that. Now we're doing 6 choose 3. So again, 6 choose 3 times 27 times negative 8. We're going to have a negative term here. 4320 x cubed y cubed. Next term, we'll notice it's alternating even odd. So 6 choose 4 times 3 squared times negative 2 all to the exponent 4 will be 2160 x squared y to the 4. And then here we're going to have a negative term because it's a negative 2 to an odd exponent. So that's going to be 576 xy to the 5 plus negative 2 to the exponent 6 is 64 y to the 6. Can I explain anything better? Anything you'd like me to elaborate on?
So instead of putting the 6 choose 3, put that in your calculator, whatever value it gives you, you multiply that by, like, let's say the 3 cubed and the negative 2 cubed, and then multiply it all together.
That's what you get. I can illustrate one of these. Like I would just go like this. 6 NCR2 times 3 to the exponent 4 times open bracket minus 2 close bracket to the exponent 2, and I get, I get that.
Okay.
Do you still have a reflection?
I got it.
Okay. All right. Oh boy. Now they give us an expansion and they want us to write it like this. So what we're going to do is we're going to go up to the top. We're going to work with the first formula and the last formula. Okay? So you know the first term is equal to 1. Now, notice, there's 1, 2, 3, 4, 5, 6 terms. There's 6 terms. Therefore, what does n equal? Oh, you guys are good. So this is 5 choose 0. A to the 5 equals 1. 5 choose 0 is 1. So a to the 5 equals 1. So what does a equal? A equals 1. Now we're going to use the last expression, n choose n, b to the n. Well, we know 5, there's 5 choose 5, b to the 5, right? So b to the 5 equals the last term, 32x to the 10. How are we going to solve for b? b equals 2x squared. Sounds good. We're going to take the 5th root, right, to the 5th, to the 5th. So 5 times 1 over 5 is b. 32x to the 10th to the 5th. What's the 5th root of 32? What multiplied by itself 5 times gives us 32? So it's 2. b equals 2. And 10 to the 5th, when you have a power to a power, you multiply exponents. 10 divided by 5 is 2. So the form of this expansion in this form is 1 plus 2x squared to the 5.
Is it to the root of 5?
To the exponent 5.
No, like on the...
This is the 5th root.
Oh, 1/5.
1 over 5, yeah. That's the first one. We'll do half of the next one. Can I explain anything better? No? Everything's okay? Okay. So, We have to do, guys, 3 more pages, and then I'll do recursive formula tomorrow along with geometric sequence. No, we're doing, huh? No, it's not. Ready? We have to do half of tomorrow's lesson. Sorry. Maybe I should stop it and start again, yeah?